We welcome to all of you in our easy learning program. So today I will again continue. My topic is magnetic effect of current. It is the second lecture of this chapter. इसमें हमने 4 lectures बनाए हैं. The total topic is divided into 4 parts, and one is for the summary and numerical problem also. I will give you a booklet of my notes. उसमें मैंने पूरी किताब को नहीं छापा है, बल्कि वो नोट्स जो बहुत ज़रूरी होते हैं बच्चों को पढ़ने, अगर बच्चे उन्हीं नोट्स को पढ़ के याद कर लें तो जो कमज़ोर बच्चे हैं उनका काम आसानी से हो जाएगा. क्योंकि 2 तरीके होते हैं पढ़ने के. एक तो ये है कि एक हर चीज़ को थॉरोली पढ़ो, और थॉरोली पढ़ोगे तो उससे आपके मार्क्स अच्छे आएंगे तो आपकी इंटेलिजेंसी बन जाएगी. लेकिन कुछ बच्चों के साथ मजबूरी होती है कि वो मेहनत भी करना चाहते हैं और हो भी नहीं पाती, नंबर भी नहीं आते. तो उनके लिए वो नोट्स बहुत अच्छे हैं. उनको पढ़ेंगे तो उनको से अच्छे नंबर आने के पूरे चांसेस होते हैं. सो टुडे आई वांट टू डिस्कस अबाउट द मैग्नेटिक इफेक्ट ऑफ करंट. लास्ट टर्न पे मैंने डिस्कस किया था कि जब एक वायर से करंट पास करते हैं तो इसके सराउंडिंग्स में एक मैग्नेटिक फील्ड पैदा हो जाती है, विच इज़ स्टडी बाय द बायोट-सावर्ट लॉ. And I have discussed there bahut-Savart's law, and that is depend on the dl element, and it is inversely proportional to the square of distance and sin theta. Today I will discuss its another property. अगर एक मूविंग चार्ज को, अगर हम एक मूविंग चार्ज को मैग्नेटिक फील्ड में रखते हैं तो इट डिपेंड ऑन द सर्टेन फैक्टर, दैट इज वेलोसिटी फैक्टर, एंड डिपेंड ऑन द वैल्यू ऑफ द चार्ज फ्लोइंग थ्रू इट. सो आई कैन से फोर्स ऑन अ मूविंग चार्ज, force on a moving charge in a uniform magnetic field. Uniform magnetic field. So let us consider the certain value of the current flowing in a conductor, and if we placed in a uniform magnetic field, this is the direction of magnetic field, and this is the direction of charge q, and this is sin theta. So there will be a force set up into it, which is perpendicular to the both, can be explained on the basis of Fleming left hand rule. Thumb will show the direction of force, and first finger will show the direction of magnetic field, and middle finger will show the direction of motion of charge, means velocity factor. If this is 0, it means both velocity factor and the magnetic field both are in the same direction, so force will be 0. But if it is at 90 degree, it will be maximum. So I can say the force on a charge, is directly proportional to the charge and F is directly proportional to the sine theta. So if I remove the proportional sign, so I will be write down a constant sign, and this constant sign is magnetic field. Right? So this is the force experience in a uniform perpendicular magnetic field. So we can say if theta is equal to 0, so F is equal to QVB. Right? If theta is equal to 90 degree, if theta is equal to 90 degree, then I can say sine 90 will be is equal to 1. So it will be 0 and it is 0. Right? So we can say it is maximum. This is QVB. And this thing can be explained, the force can be explained here, Q V cross B according to the cross product. Because I know that cross product A cross B is equal to mod of A mod of B sine theta into neta is a unit vector which represent a third vector which is perpendicular to both A and B, जो हमने 11th क्लास में आप लोगों को प्रॉपरली डिफाइन किया है. तो हम कह सकते हैं hence the force is perpendicular to V and B both. Right? So this is nothing but we can say F is equal to QVB. So the direction of force can be explained. The direction of force can be explained on the basis of left hand rule, Fleming rule. According to him, three fingers including thumb, including thumb are perpendicular to each other, then first finger shows the direction of magnetic field B, and middle for velocity factor, while thumb will be show the direction, shows the direction. So this is nothing but is the force experienced by a charge. When charge is placed in a uniform magnetic field, it will be experience a force. So this is nothing but it is the explanation of the force experienced in a uniform magnetic field. Now I want to discuss another concept of the magnetic effect of current. This is also very important. Force on a current carrying conductor, force on a current carrying conductor placed in a uniform magnetic field, placed in a uniform magnetic field. Right? Let us consider this is nothing but it is your wire. Yeah, you can say there is a conductor. So when it plays in a uniform magnetic field, the current carrying conductor, so this is the electron. So electron will be drift toward the positive potential from negative side. So it will experience a magnetic field, and this is the velocity. So this is what is called force, which is perpendicular to the both. So I can say, let us consider the area of cross section is L, and L be the length of this, and be the total number per unit volume, that is AL. So there will be a certain factors on which the force is given. So I will be drive that points. So let us consider and be the number of turns, and be the number of turns. And be the number of electrons E, that is N is equal to 1 upon total per unit length, where A be the cross-sectional area, and length is L, right? So what will be the force experience? The force experienced by the each electron. The force experienced by each electrons each इलेक्ट्रॉन्स, अभी अभी आपने इसको डिस्कस किया है, F इज इक्वल टू माइनस क्यू, यानी कि क्यू चार्ज होता है इलेक्ट्रॉन पे, सो आई रिप्रेजेंट हेयर इट वेयर वीड इज ड्रिफ्ट वेलोसिटी ऑफ इलेक्ट्रॉन्स। अभी अभी रिसेंटली आपने इसको डिस्कस किया है, क्यू वी बी। सो दिस कैन बी राइट डाउन एज, so this is the force on each electron. Then I can say, then the total force F is equal to total volume. I can say this is NaL, means the total number of electron, that is F. So this can be write down as F is equal to minus N EAL into VD cross B, right? So here is a certain kind of the dot product is used. This is B cross C. So this is nothing but स्केलर ट्रिपल प्रोडक्ट। अगर हम इसकी साइकिल चेंज कर देते हैं, C क्रॉस B, that is A, so this can be write down here minus. This can also be changed as C dot B cross A, B cross A, right? So according to the dot product, this can be write down as, F. I will write down, definitely there will be sign of vector. This is NE AVD and L vector will come inside. This can be write down as this, minus side will be also inside. So this can be write down as, this is I, this is L cross B. So hence I can say, hence we can say here, we can say force is perpendicular to the L and B both, यानी कि ये दोनों के परपेंडिकुलर होगा। Another special cases I can also discuss here. I know that if F is equal to ILB sin theta, because L cross B is a vector product, right? So I am considering it is a magnitude, so I am not writing a unit vector, but it is necessary to write down unit vector also. But I am writing here in terms of magnitude. So magnitude of the unit vector is 1. So it may be omitted. So I can write this also. There is no problem. If theta is equal to 0, so I can say the force will be 0. This is the same factor as used in motion of the charged particle in a uniform magnetic field. If theta is equal to 90 degree, then sin 90 is equal to 1. So I can say this is equal to the resultant force acting on a charged particle, which is maximum when both the length vector and magnetic field intensity both are perpendicular. Suppose this is the field, this is north pole and this is south pole, the line of force coming towards it, right? So the direction of magnetic field is this. If I place it means like this, so it means the direction is parallel to the, it means no more force acting on that. But if I placed like a perpendicular direction, so here will be a maximum force acting on that. So this is also a very, very important, means most important question. So this is not a basically problem for all of you. I am explaining all the thing properly. So you should also learn all the thing properly and uniformly, then you will understand the physics. So it was your second article related to this chapter. I want to explain another important thing which is called force between two parallel current carrying conductor, two parallel current carrying conductor, current carrying conductor. यानी कि अगर हम दो वायर्स को, सिंपली वायर्स, दो वायर जिनके अंदर से करंट फ्लो कर रहा है, अगर हम उनको बहुत क्लोज रख दें तो उनमें एक फोर्स सेटअप हो जाता है. एंड दैट वैल्यू ऑफ द फोर्स इज डिपेंड द डिस्टेंस बिटवीन them and the direction of current also. So I am explaining here the force on a current carrying conductor. Suppose ये एक आपका current carrying conductor है I1. So due to this there will be a certain value of the magnetic field at that point, right? So let us consider I1 be the current, I1 be the current passes through a conductor, passes through a conductor. So definitely it is surrounded by a magnetic field. Then magnetic field intensity due to long wire, जो हमने कहा था आपके सिलेबस में नहीं है, लेकिन उस फॉर्मूले को यूज किया जाएगा. So this can be explained as mu 0 I1 by 2 pi r. आपको शायद याद हो कि हमने ये फॉर्मूला ड्राइव नहीं किया था, लेकिन लिखा था कि ये फॉर्मूला आपको आगे यूज होगा. That formula, the derivation of that formula is not in your syllabus, so I have not write more words regarding this, right? So this is nothing but, this is your B is equal to mu 0 I1 2 pi r. Now if I placed another wire, but the current is in same direction, current is in same direction. So there will be a certain magnetic field also in this direction. So it will be experience a force inside. This is called F1, or we can say F, and here is also F. So I can say there will be a force experienced by it. Right? So now the force experienced by another conductor carrying current I1, then force will be I1 LB. It is maximum because it is perpendicular to the length. It means this force is perpendicular to this and this both. So it means I can say sin theta will be 90, so I have write down. So this is your nothing but it is your first equation, and this is your second equation. If I write down here from equation first and second, तो हम क्या करेंगे, यहाँ से b की वैल्यू निकाल कर इसके अंदर पुट कर देंगे. फ्रॉम इक्वेशन first and second. So I can say F is equal to I1 L, and B is equal to what? I1. This is 2 pi r, right? Where L be the length of this conductor. So this can be write down as force per unit length. This can be write down as force per unit length. This is equal to 2 pi, and this is I1, I2, that is R also. So this value is nothing but it is 2 into 10 to the power minus 7 I1 I2 by R. This is the force experienced per unit length. If the direction of current is same, the force is the force of attraction in both, right? If the direction is opposite, so here will be a force of repulsion will be set up. If the direction of current is same, then attractive force will be set up. Attractive force will be set up. Force will be set up. Right? If direction is opposite, then force is repulsive. Then force is repulsive. Right? So this is nothing but the force between the two parallel current carrying conductor. This is also a very important article. regarding view of exam, but you should have a proper knowledge of everything, I am sure. मैं आपसे यही कहूँगा कि अगर आप इंटेलिजेंट बनना चाहते हैं, आगे जीवन में कुछ सफल होना चाहते हैं, तो आप सिर्फ इम्पॉर्टेंट चीज़ों पर बेस ना रहें, बल्कि मेहनत करें और चीज़ों को अच्छे से समझने की कोशिश करें. तो दिस इज़ नथिंग बट the force between the two parallel current carrying conductor. इसमें कई बार क्वेश्चन कर लिया जाता है कि फाइंड आउट द एक्सप्रेशन फॉर द फोर्स पर यूनिट लेंथ बिटवीन द टू वायर्स. सो इसका मतलब इट विल exert a force on it and this will exert a force on it, but the magnitude of the force is never changed. I can prove it here. Suppose this is due to second mu 0 it, this is 2 pi r. Then force will be is equal to what? This will be ILB. तो जब आप इसको पुट करेंगे तो वही चीज़ आपके सामने आ जाएगी. So there is no difference. This is 2 pi r. So again we received the same formula. It means the both wire both current carrying conductor will experience a force on both each other, but they are equal. There is no difference. So इसमें कभी कभी वो पूछ लेता है find out the expression by the expression of the force between the two current carrying conductor, लेकिन वो साथ में कह देता है define also 1 एम्पियर. तो आपको इसी मेथड से एम्पियर की 1 एम्पियर की डेफिनेशन को लिखना पड़ेगा, वरना एग्जामिनर आपको फुल मार्क्स नहीं देगा. आई एम श्योर. सो आई कैन से एफ per unit length is equal to 2 into 10 to the power minus 7. If distance is 1 meter means unity, then current will be is equal to I1 I2 1 ampere. Right? So I can say if force per unit length, force per unit length is how much? Is 2 into 10 to the power minus 7 Newton, and conductors separated by a distance separated by our distance 1 meter या unit distance, then current will be current will be 1 ampere. 1 ampere. Okay? So I think this definition is not a problem for all of you. क्योंकि 1 एम्पियर को हम दूसरे तरीके से भी डिफाइन कर सकते हैं. आपने ओम्स लॉ के अकॉर्डिंग भी डिफाइन की है. V इज इक्वल टू क्या होता है? IR होता है. तो I इज इक्वल टू क्या होता है? V बाई R. तो I 1 एम्पियर को आप कैसे डिफाइन करते हो? इफ पोटेंशियल इज 1 वोल्ट and this is also a definition of 1 ampere, right? एक और आपने डेफिनेशन 1 एम्पियर की लिखी थी, दैट इज क्यू. तो 1 एम्पियर इज इक्वल टू 1 कूलम 1 सेकेंड. दिस इज ऑल्सो अ डेफिनेशन ऑफ द 1 एम्पियर. सो अगर इस केस में आप ये दोनों डेफिनेशन लिख के आते हैं तो आपको नंबर नहीं मिलेंगे, क्योंकि वो कहता है कि इसी के फॉर्मूले से आप ड्राइव करें. इट मीन्स हैंस यू ड्राइव a 1 ampere, right? So how we can find out the question is here. Suppose there is a certain value of the current flowing through it, that is 2 ampere, 2 ampere, and another wire is placed. Here is a current flowing is suppose 4, and it is nothing but it is placed at 1 centimeter distance. So 1 centimeter is equal to 10 to the power minus 2 meter. It is necessary to convert, because I solve my problem in MKS system. So I will be write down it. This is equal to 2 into 10 to the power minus 7, right? This is I1, I2, and here will be R. So this formula can also be write down as 4. जैसे अभी इसको दोबारा से लिख देंगे. नाउ आई वांट टू फर्स्ट सॉल्व इट. सो दिस इज इक्वल टू एफ एल. सो दिस इज 2 into 10 to the power minus 7. This is 2, this is 4, and this is 10 to the power minus 2. So this 2 to the 4, 16. And this is minus 2 ऊपर ले जाएंगे, so this is 10 to the power. So this is the force experience per unit length. So this can be write down as. So these are the certain very important examples for this question, and this is all 3-1 questions. Yeah, derivation are the important regarding point of view of your exam. Somewhere it can be write down as here. This is mu 0 by 2 pi I1 I2 by R. So this also can write down. अगर हम इसको 2 से मल्टीप्लाइड कर दें तो इसको भी 2 से मल्टीप्लाइड करना पड़ेगा. सो कुछ किताबों में इस तरह से भी लिखा जाता है. तो दिस इज नथिंग बट इज द सेम एक्सप्लेनेशन. ओके, तो आप लोगों को शायद अच्छे से समझ में आया होगा. here is a 3 article which is the most important. I just try to sort my derivation very easy way. और सभी स्टूडेंट को, हम दुनिया भर के स्टूडेंट्स के लिए ये रिकॉर्डिंग करते हैं, तो हम सभी को नज़र में रखते हुए, होशियार बच्चों को भी और थोड़े से कमज़ोर बच्चों के लिए भी, ताकि उनको भी फिज़िक्स अच्छे से समझ में आए. तो हम जनरली स्लो पढ़ाते हैं. तो स्लो पढ़ाने का हमारा उद्देश्य ये नहीं है कि हम स्लो पढ़ाते हैं, लेकिन हमारे जो प्रोग्राम है उसका मतलब ही ये है कि इजी ऑनलाइन, मतलब हर चीज़ को इजी करा के. जैसे आप क्लासरूम में होते हैं तो क्लासरूम में आपको टीचर ब्लैक बोर्ड पे पढ़ाते हैं, तो हम भी आपको ब्लैक बोर्ड पे पढ़ाते हैं, बट वी यूज़ द न्यू टेक्नोलॉजी, दिस इज़ कॉल्ड इंटरनेट। तो जब भी आप अपनी वीडियोस वगैरह को देखते हैं तो हेयरिंग एड्स ज़रूर लें, जिससे आपको साउंड में कोई प्रॉब्लम्स नहीं आएगी, क्योंकि कितनी भी हम इफ़ेक्टिव साउंड बनाने की कोशिश करें, आपके मोबाइल के ऊपर भी डिपेंड करता है। तो कोशिश करें आप हियरिंग एड्स को यूज़ करें। सो दिस इज़ नथिंग बट इज़ today's topic of my today's lecture. So thank you very much for your cooperation and concentration. Thank you very much.